WSP Parsons Brinkerhoff conducted a productivity analysis on a high-rise student living and commerce development at the corner of 6th and Green Street in the heart of campus town at the University of Illinois at Urbana-Champaign. A crew of 8 workers was observed placing steel rebar and formwork near an elevator shaft in the center of the structure. Crew balance charts, process charts, and flow diagrams were used to track the productivity of the operation as is, and were then used to devise several improvements to this operation by removing a worker and the temporary laydown area, redistributing the work amongst the workers in several ways, and increasing the supervision over these workers. Costs for each of the observed activities were developed using RS Means 2019. In the end, the contractor should decide whether to pay a crew of 7 for high productivity or a crew of 6 for slightly lower productivity.
Now I will be talking about area of study. The activities being performed. The framework placements are in yellow, and the red-blue are steel rebar placements. Construction worker on site are 9 workers, 1 inside the rebar cage and 1 foreman. There are 2 construction processes involved. The first one is plain steel reinforcement bars, and the second one is forms in place walls. The typical crew for this process is 4 rodmen, which should have an output of 2.9 tons of A615 steel per day. The total cost for this activity is $1,950 per ton. The observed crews has 4 workers performing contributory tasks related to the placement of steel rebars. A rodman's hourly based compensation is $54.3 per hour. With overhead and profit, each of this worker cost is $83.7 per hour. The other construction process involved is form in place walls. The typical output for this work is 370 square feet of contact area per day. The crew for this activity is C2, that is typically comprised of 1 foreman, 4 carpenter, and 1 labor. The unit cost for wall framework in place is $12.3 per each square feet of contact areas. The condition of working area and the way activities was planned make the execution to be performed with a smaller group of workers than the typical forming crew. During the observation, it was evident that 2 carpenters were the ones doing all the contributory work for this task. A helper eventually assisted the other 2 for specific requirements, although wasn't a steady help for the execution of this activity.
We conducted our observation on Tuesday, April 9th at 7 a.m. It was sunny, but had rained in the previous few days because certain areas of the site were slightly flooded. In terms of safety, the site is well fenced off to discourage the public from entering and placing themselves in harm's way. Areas of the fence have clear warning signs and instructions for visitors to meet with the construction manager before entering the site. On Green Street, a temporary walkway has been constructed to allow pedestrians to safely navigate around the site while out of the way of cars. There is an additional alleyway situated next to the site on Wright Street, and connected to that is a wooden ramp for workers to enter the site, but is clearly marked for employee use only, to discourage trespassing. All personnel on site are dressed in the appropriate personal protection equipment. They are wearing fluorescent yellow or orange shirts, hard hats, safety glasses, gloves, and work boots. Thus, they are visible to drivers of heavy machinery and protected from falling objects or against cuts and scrapes. There are also safety precautions in place regarding the machinery on site. For example, all excavators are left with their buckets on the ground and facing upward when work is not taking place. Additionally, the base of the tower crane is encased in a wooden structure with only 1 door to allow restricted access to the crane by only trained and certified personnel. The site can be split into 2 different sections in terms of the work that is taking place. Firstly, the south side of the site seems to have progressed further in the construction process than the north side. This is probably planned so that construction can be staggered and resources can be divided evenly, without needing double the amount of workers or equipment. Large strips of fabric, which can be insulation or a vapor barrier, have been pinned to the steel piles around the perimeter of the site. Inside the site, rebar has been placed throughout the entire area, and wooden formwork has been placed across the division between the south and north sides in preparation for a concrete pour. There is also green rebar that will be housed inside concrete columns after the pour. A section around the base of the tower crane has already been poured and serves as a smaller laydown and work area. There are 2 areas in this section that have visible formwork structures. One has been completed while the other formwork section is still being put together, but will eventually look like a larger version of the other 2 formwork boxes. They will possibly make way for an elevator shaft or stairways. The north side of the site is still in the excavation phase. A large excavator situated by the 6th Street entrance to the site is transferring earth into a truck, while a much smaller excavator looks to be leveling the ground of the site. The site looks to have been excavated 1 story and is surrounded by steel piles. The northeast of this site has been chosen as a laydown area for various materials, such as bundles of rebar, concrete bricks, strips of wood, and the fabric insulation that will line the site perimeter.
The process charts and flow diagram can be seen here. The process charts outline who participated in a construction activity such that it shows what they are doing and how they completed the activity. The flow diagram outlines the location of the activities involved in the construction process. Our construction site had 2 process charts, one for the rebar placement, which is located next to the elevator shaft, and another for the formwork placement, which is part of the elevator shaft. From the flow diagram, it can be seen that the rebar is transported from the stockpile to the temporary laydown area. It is then transported from the temporary laydown area to the cutting area. Once the rebar has been cut to size, it is transported from the cutting area to the workers near the elevator shaft. The appropriate symbols for the different processes are shown. More specifically, the rebar is transported approximately 15 feet by a laborer to the cutting area, where it is cut to length by laborer number 6. Laborer number 6 then transports it to the installation area by feeding it through the frame, where it is installed by laborer number 7. Laborer number 1 then inspects the installed rebar. While that is happening, the wood strips that are used for the elevator formwork are transported 2 feet by laborer number 5 to the elevator shaft, where it is nailed in place by laborer number 4. They are then inspected by laborer number 3.
We chose to study a process that consisted of 7 workers in and around the elevator shaft, and we were able to assemble a crew balance chart. Labor 1 is seen inspecting previous work for 30 seconds of the 2 minutes and 30 seconds in the crew balance, but is idle for the remainder of the time. Labor number 2 is completely idle for the entirety of our observation and seems redundant. Labor number 3 is much more engaged in the process than the previous 2 workers and is only idle for 30 seconds of the cycle, while filling the remainder of the time by nailing the formwork together or inspecting labor number 4's work. Labor number 4 is active for almost the entire cycle and is only idle for the last 15 seconds. He either assembles the formwork or transports the sections that he needs to put in place. Labor number 5 is another underutilized worker who transports material for 30 seconds and spends the remainder of the cycle idle. Labor number 6 spends the majority of the cycle either cutting, transporting, or placing and arranging rebar and is only idle for 15 seconds. Lastly, labor number 7 spends the first minute of the cycle idle and then finishes the cycle by tying and placing rebar. The most obvious problem with our system is that all of the workers in the system spend some time idle. While labors 3, 4, and 6 only spend 15 to 30 seconds idle, the other workers spend significantly more time not actively engaged in the construction process. By analyzing our process chart, we find that there are also multiple instances of delays in the form of temporary storage of materials. The materials need to be transported from the stockpile area in the northeast of the site to the elevator shaft area, but then are just laid in that area until they are used. The inactive workers and delays caused by temporary storage should be reconfigured to make the entire system more efficient and productive.
Several improvements may be made to improve the productivity and cost efficiency of the observed crew. One worker, laborer number 2, is seen as idle throughout the whole entire cycle, suggesting that this crew may be too large for the given task to be completed during this observation. The reduction of crew size may drastically reduce labor costs over time, while also improving overall productivity. Labor number 1 spends 1 minute of the cycle inspecting previously performed work and is idle for the remainder of the cycle. Laborer number 1 could pick up this inspection work from laborer number 3, bring up laborer number 3 to assist laborer number 4 in transporting formwork and nailing in time. This also eliminates idle time of laborer number 1. Another improvement to this process may be the removal of the temporary storage areas of rebar and wood formwork and instead bringing the required rebar and formwork directly from the staging area to the cutting and ore preparation area. This will result in the elimination of delays in the flow diagrams for each material. It may also reduce the amount of time required to return unused materials to the staging area later on.
So for the proposal number 2, we rearranged and divided some duties between the laborers after giving up on labor 2. So labor 3 took the transportation of the form section from labor 4 that made labor 4 start nailing and tying earlier. On the other hand, there were other divisions and tasks. For instance, the transportation of the wood stripes is divided between labor 5 and 7. The transportation of rebars is divided between labor 6 and 7. And we divided the tying and placing rebar mission between labor 5 and 7. Overall, the entire changes and splitting had saved us 15 seconds per cycle. Proposal 3, assuming that we cannot fire any labor, so instead of placing labor 2 outside the elevator shaft, we place him inside to help labor 3 and 4. That action will make labor 2 nail and tie instead of labor 3, leaving labor 3 responsible inspecting the work of labor 4 and 2. The division of duties between labor 5 and 6 and 7 is similar to what was indicated in proposal 2. So this procedure is reducing the time from 2.5 minutes to only 2 minutes per cycle. In easy wording, we saved 30 seconds per cycle. Proposal 4 is similar to Proposal 3, but reducing the amount of idle that labor is taking over the normal labor takes. Their foreman is responsible to motivate them to reduce the idle time, and this move will save us 37.5 seconds from the actual duration.
Cost analysis was calculated for labor and equipment using RS Means 2019 values. This included the hourly output of the excavator and the truck, whereas the truck was the lesser of these two outputs, which was the driving factor for the total cost of equipment. The total cost for labor plus equipment came out to $752.08 per hour. The productivity was also calculated using RS Means daily output values, since we did not have physical quantities. The productivity of the 6 rodmen was 0.091 tons per man-hour, while the unit cost was $604.96 per ton. For the structural concrete forming, the productivity was 5.78 square feet of contact area per man-hour, while the unit cost was $8.56 per square foot of contact area. For excavation, like I said earlier, the truck output was the driving factor for the productivity to come out to 12.375 cubic yards per man-hour, and the unit cost to come out to $4.22 per cubic yard.
WSB have developed 4 alternative proposals for the current construction process of the elevator shaft. Proposal 1, 3, and 4 consist of 7 crew members with different cycle time of 2 minutes and 30 seconds, 2 minutes, and 1 minute and 52 seconds, respectively. Proposal 2 consists of 6 crew members with a cycle time of 2 minutes and 15 seconds. The choice of which alternative would depend on the ability to pay for a crew that consists of 7 members with a higher productivity rate, or a crew that consists of 6 members with a 15-second difference and save the cost of an extra labor. Finally, WSB proposed 4 alternatives that are dependent on the contractor's financial ability.